start recording right now. Okay. Anyone has any question? Is the voice clear?
Hello?
Yeah.
I just wanted to ask, do we know how we're doing tests yet?
Not 100%. Okay. The lecture is going to be exactly the same. Wade, I think this is really nice way of doing lecture. The assignments is just really pushed back if you check the assignments. Why? Because we are going very slowly, and if for my class, I'm pretty sure no one has any problem because everything stays exactly the same. Your group work, your voice thread, and then assignments all are really same pattern. I didn't change anything. Everything was originally online. Is only the lectures which is online. If you are here right on the time, like just really your usual class, actually you are saving about 2 hours because you don't have to look for parking, you don't have to walk to the class, and then we are saving a lot of time for this type of virtual lectures. The only thing is we don't meet each other, but if you have any question still is just really Zoom available. So the only thing about the exam which I'm not sure, what I want to do is my plan is just to make just what you call homework. So what's the take home test? But the main question, I will make a take home test. But what I'm not sure about is if I want to make a take home test, should it be exactly on the same day that we have had the test? That's the only thing that I'm not sure about it. Because if we are really getting slower than the original lectures, do we have enough material for the next test? I think we do, but I'm just really checking how fast I can go for the classes because the original date was before the spring break, which is still we have the spring break right in the same time. So if I want to make that before the spring break, which is next Thursday, this means we have 2 lectures this week, and whatever we just cover this week means Tuesday and Thursday will be in the test, and then whatever I just do it in the next week, it can't be in the test. So then what I can see is just really at most 3 more sections that I can cover. So means it's just partially chapter 12, but chapter 12 is really connected to each other. So I'm sure I'm going to make the test at home. And then what is the pattern of the test? I'm not sure. And what is the date? I wish to be exactly on 26. Am I right? Is the date 26 next? Anyone knows what's the date of the test? So if was originally, yeah, 26. Sorry, I'm not sure what's the exact plan, but probably today, tomorrow, I will make a plan somehow to say, do we have a test exactly on 26, which is before the spring break, or we make it after the spring break? And then that's again is a take-home test, and it's just with the limited time, and then through the Zoom, and it's just really same time of exam, or sometimes for my classes I have them to do some more problems, and then I give them 24 hours to do it. So then it's not really certain what we want to do. Sorry. Give me about 1 day more to fix it. Any other question? Any other question?
Well, I had a question on the homework from 11.8. I couldn't solve number 3. 11.8 from the homework.
Okay. So Angelina, Angelica, am I right? So
yes.
What it is, if you can just do a favorite for me, I have changed the this, what is it, video classes to be half an hour before the class time and a little bit after the class time. Okay,
Okay.
so in order to save our time when I'm lecturing, to be right at 2:30, so we can answer your questions about the homework and about the just group works or about anything more than just whatever is the lecture time before the class time, which is at 2 to 2:30, and after the class time, which however you want. So because I'm available after the class time, so I will log into the web assign after finishing the lectures and I'll answer your question. Okay,
Okay, that's fine.
so this is for 12 point
11.8 number 3.
number 3. Okay,
Yeah.
so I will do it after the class.
Okay, that's fine. Thank you.
Okay, any question or concern about the way that we are making right now? I don't see myself in this video. Is it everything fine?
Yeah, everything is fine. We can see you.
Yeah.
But I don't see myself. I don't know where is it, however it is, it's fine. Okay, as long as you see me, that's fine. Okay, I have, yeah, I have just most of you available. So it seems I have 25 participants. So this means really great. So it's almost the same as our class. And again, if you have something to share with me, just please just unmute yourself. Okay, don't type it. I'm so sorry. I don't see the type when I maximize the page. So just very quickly remind you where we are at. So we've been doing 12.2, right? So in 12.2, it was what, double integration of a general region, but we couldn't just really say this is a general region because it wasn't really that much general. And the reason was it was just really two types of region that we could do the integration. So main thing that we need to remember is whenever I have this what is integration, the first one has to be always a constant. So there is no way to make the double integral or to solve the double integral if the limits of integration is not constant. Why? Because remember, this is supposed to be at the end the volume of something. And when we say volume of something, it has to be a number. So that's why the first limits must be always the constant, and then the inside it can be either one constant or not constant. Okay, so there are two types. Either your x's are constants, so means you started with the x's and then your inside is the y's, or the other one which your y's is constant, so then you started with the y's. So that's the key part. I have to remember this first thing must be always numbers. So you can't have the curves or what we call equation in terms of x and y right here in this part. But here, as we see, it's fine, right? So this is just really when you have the inside of your or the second term, which is the dx, can be in terms of x or y, that's fine. But the first limits of integration must be always the constant. And I said, what's the reason? The reason is at the end, this is supposed to be a volume, which is going to be a number. There is no way to be a variable or a function in terms of x and y. Okay, so this is what we have started last time, these two types. And then we haven't started, I think, any type. I think we practice this problem, right? Am I right? Anyone can remember? Did we try this problem? No?
I think we did, but
Yes, we did do the
I don't think we
problem.
finished.
Okay. If you think I just really quickly what graph these two. So the main thing that I need to find what's the limits of integration is to see this region in the two-dimensional graph. So then the main thing that you need is just really what is the intersection of these two curves, which is going to be like set the equations equal, and then we got the intersection. We got the intersection to be minus x squared both sides to be plus minus 1. So then there were two parabolas, and then it's just from -1 to the +1, and one of them is shifting 1 unit, because this is just one that tells you it's shifting 1 unit up. So then I make it with the green. So this is the one which is shifting 1 unit up, and the other one is just a simple parabola, but the intersection is right here. So then I just make it right over here. It's not simple because it's a little bit tighter because of twice, but that's just how it is. And then the region of integration was right over here. This is the region of integration, and we have decided to make it type 1 because this is just going to be numbers, right? So whatever is the constant must be first. So the limits from -1 to 1 is constant. So that's just your beginning point. And then your inside is just the dy. So in order to write the dy, we have to really walk in direction of the y. So we need to just walk in the direction of y to see what is increasing. So we are moving along the y. The first thing that we hit is going to be the lower limit. So it seems the lower limit is the blue curve, which was originally 1 plus x squared. And then the upper limit is just keep going. So the upper limit is just the green. Oops, I made a mistake. The blue one was the 2x squared. Okay, so the upper one is the green one, which is 1 plus x squared, and then you start to integrate this, which is 2x sine y. I believe I finished this one. I don't know why I feel I finished this one. I made the u substitution and I finished this one. Okay,
we did finish it. We got the answer to 0.
Yeah, exactly. But that's fine. We could just really practice one more time. Maybe I can, because I just graphed it one more time, I can ask you whether I could do this one in type 2, right? So for most of the region, it's possible to do either way. It is possible to do either way, but one of them is harder, right? So for example, if the plan is for the same graph that we have had over there to make it in type 2, so then we have the lower limit. So let me just have the highlighter. So then this is the lower limit for y, and this is the all the way up there. So this is just really all the way from 0 to the 2. So that's just the highest point for the y direction. If we're supposed to write it from 0 to 2 for the dy, but the dx is a big problem. If I'm looking to the x direction, it seems moving to the x direction is not really constant, right? Somehow by here still I am just having just my curves or parabolas, which is the y equals 2x squared, but after this point, which is right there, and we know what it is, it's just the line of y equals 1. The lines or the endpoints are not the same. It's just really from here to here, and then it's here from to here to here. So from what it's from the 0 to the 1, we have different limits from 0 to 1, and then from 1 to 2. So this means you have to really split it out to the pieces. So this is one piece, and then this is another piece, and then this is going to be another piece, right? And then that's just not a good idea. We don't like to repeat the same integration 3 times. So that's why we prefer to go with the type 1. But again, it's possible most of them to do in both. One of them is always easier than the other one, okay? So we have 3 more examples to practice this type of integration. The next one is finding the volume. Finding the volume, so means what? That's just original concept of the double integration. Volume is going to be always double integration of something. Okay, so this is just original concept. So means I have to have integrand, number one, then I have to have a region of integration. Okay, so I will just remind you the integrand is going to be always the top solid, right? Is I can call it really the roof of my solid. So whatever is on top is going to be the integrand, and then this is just always what's the base of your graph is. Okay, so whatever is on ground, whatever is on the xy plane, right? So for now, it seems there is only one surface given to me, and that's just going to be that whatever is the top. And for now, I'm not worried about how to graph, even though I know how to graph. That one is just a paraboloid. But I need to set the limits of integration, as I said, which is 80% of your credit is just the XY plane or the region of integration. So this is what I need to graph it. This is what I need to graph. So that gives me the limits of integration, not the roof. The roof is just give me my integrand. So there are always two different, I will say, graph. One in 3-dimensional, I needed to see what's the top, what's the integrand. And the other one is just my, what is it? The 2-dimensional graph, which gives me the limits of integration, okay? So I will start with the, first of all, let's just say there are two lines. This part is algebra. I try to remind you as much as you need. So I have a line of y equals to x, and then I have the line of y equals x squared, sorry, parabola of the y equals x squared, and then the intersection is going to be set them equal, bring it one side, factor the x out, so that gives you x equals 0 and x equals 2. Actually, that tells me I don't need to make the graph in negative piece, so it's enough to make it only in positive, because I have intersection of 0 and 2. And if I plug in anywhere here or here, so that tells me the y value for 0 is going to be 0, y value for the 2 is going to be 4. So y value in 2 is going to be 4. I just make it in different color. So my y equals x squared goes like this. And then if I have 1 and then 2 units, and then the line of y equals, okay, y equals to x. If I plug in x equals 1, I will get 2. And if I plug in 2, I will get 4. So this is 4 units. Okay, so this is the line of y equals to x. So seems that's the region I'm looking for. This is the region I'm looking for. Let's just really make this one nicer. This is going up. That's a y. This is 4, and this is a 2. Okay, so then the question is it easier to do this one in type 2 or type 1? Is it easier to do this one in type 2, in type 1? Any idea? Can you please put your comments for me? Any idea? No one? Type 2, yeah, Brooke says type 2. Any other idea? Can I do it in type 1? Yeah, so it seems, Brooke, I like to hear your voice if it's possible. If not, it's fine. So yeah, that's true, because it's possible to do in both ways. I will tell you now, whatever looks like a triangle region, it seems is okay to do in both ways, and then we will try in both ways, and then whichever was easier, we can select that one. Okay, so let's just say if your plan is to start with the type 1. Okay, so let's say your plan is to start with the type 1. So if this is going to be type 1, what does it mean? You have to start with the x. So this is going to be the dx limits. which the dx limit is just the smallest value of the x is right over here, the biggest value of the x is right over here. So you go from 0 to 2. And then this is just the next term, which is the dy. As I mentioned, in order to just write the limits of inner one, for me now is the dy, you're just going to move on the y direction, you're walking on the y direction, it's always down to up. Why? Because that's the way the y is increasing, right? So whatever you hit first, seems here is the blue curve, is going to be y equals x squared. So that's just really this lower limit, and whatever is top is bigger, and then that's just going to be the upper limit. For which one? For this one was the line of 2x. So I have started from this blue, which was y equals x squared, and then the last point was y equals 1 plus x. Oops, sorry. Yeah, that was 2x. Okay. So this is the limits for x. Is there any question how I set my limits for the y? First x and then y. Do you have any question? Do you have any question?
I have a question.
Mm-hmm.
So for the inner limits of integration, do we just always use what the two equations for the lines are?
Yeah, that's a very good question. Do we always use them? Yes, we can use them always, but do we use exactly the same way they are? I can say no, because I'm going to practice type 2, and then I have to remember, if I'm writing the limits for the y, it has to be y as a function of x, right? Because these are for the y's. But if I switch them, those are for the x, so you need to solve it for the x. Yes, we do use them, but not the way exactly they look like. So sometimes you just change it in terms of x or y, depends on, I'm writing for the y, so that's just in terms of the y. If I write it for the x, it has to be in terms of the x.
Okay, thank you.
Thank you for asking. So then, as I said, this thing that we are looking for, which is just the roof or the top, for us is given to be this paraboloid. So that's your integrand. Integrand is going to be x squared plus y squared, right? So integrand is going to be x squared plus y squared. But for this problem is easy because I don't have anything else. Is the only z which is available in this problem is my surface, and that's just going to be the integrand. Okay, so remember again one more time, what you are integrating is just really whatever is your z, or the function as x and y written, right? So the function in terms of x and y is going to be your your integrand. Okay, so that's for us, is this one is the only one which is available. I just repeat the same process, but this time to see the type 2. At least for this problem, it's not that much different, but let's see. If you want to just do it, this problem with the type 2, so that means you have to write the limits of integration for the y first. So if I use the highlighter, so for the y, seems this is the beginning, this is the end one, right? So this is how your values of the y is changing from 0 to the 4, from 0 to the 4. So this is from 0 to the 4 for the y, and the next 10 is the x's. The next 10 is the x's. So the inner one is going to be the x's. So if I want to write for the x's, I have to move from left to the right, right? So this is just x's. X's are the one that is moving from left to the right. So I'm moving from left to the right, and then the first thing that I hit and the last thing that I hit. So this is changes for the dx, and this one was changes for the dy. Okay, so this is changes for the dx. Okay, so again, you can't write here the lower limit, which is the green line, is y equals 2x. Why? Because I'm writing for the x, so it has to be, no, y equals 2x is basically x equals half of the y. So what I need to write down over here is limits for the x, it has to be in terms of the y, so which is half of the y. Does it make sense?
Yeah.
For some reason, it has been disconnected. I have no idea why. So is recording and you see my page, right? Do you see my screen?
Yes, I see. We see your screen. Yeah,
Okay,
what you're writing.
Okay. So then how about the next line? So it was originally y equals x squared, but that's not what I'm looking for because it has to be in terms of x. So it's just going to be plus minus y, sorry, plus minus the square root of the y. This is just a positive square root of the y. Why? Because we are in, what is it, right side, right? So the right side is positive. So the right side of the x, or the right hand of my y equals x squared is going to be the positive one. So then the limits of integration looks like this, but it doesn't change anything in my integrand. It still is x squared plus y squared, huh? Maybe because I don't like to work with the radical or just really make another u substitution, I prefer to go by type 1. But as you see, the integration for such a this polynomial, that it doesn't matter that much. I mean, either one is possible. Either one is really possible, okay? So the main thing that I have to remember is just if you are writing the, what is it, limits of integration, first of all, you have to decide which one is first. Is it constant? It must be constant. And which one is next? If the y is next, you have to solve for y. If the x is next, you have to solve for the y. But the answer is the same. Either one is fine. You can do either one.
I have a question.
Please. Oopsie.
So for the inside integration between type 1 and type 2, how do we decide which way we integrate it? Because for type 1, we did it from x squared to 2x. But then for type 2, we did it from y over 2 to square root of y.
Okay.
Which are like they're the opposite ones. So just like, how do we read it for the y? I guess.
Read it or
like just pick which way we integrate for the looking at the graphs.
so which if you're asking about integration, no matter what, you have to always start from inner one, right?
Okay.
Okay. So whatever is inside is going to be first. So for the type 1, dy is inside, you start to integrate in terms of the y, plug in the x squared and 2x, and then next term is for the x. For the second one, which is type 2, you have to start with the dx, I mean, integrate in terms of the x, and then y is the constant, you take care of the limits, and then you do it with respect to the y. Did I answer the question?
I think my question is the actual limits of integration, not the order of it. So like for type 1, we integrated it from the bottom function of the graph to the top. And then for the second one, we did it from the top to the bottom.
Okay.
You
so
see what I mean?
Then, yes. Okay. So remember for the y, because the y-axis is going to be just really vertical one, so you go top, bottom one. But for the x, because the x-axis is left to the right, you have to say it left to the right. Okay. So it's not top, bottom, it's left, right. Okay. So that's why I'm making that arrows. So that says that if you are using the dx, you are going from left is the lower, right is the top or the upper limit. If you are working along the y-axis, because that's the way y is increasing, right? So from the bottom to the top. So then that's just really true. You're having the bottom to be your lower limit, the top to be the upper limit. Okay, so it's just really the way that x-axis and y-axis is increasing. Okay. Does it make sense?
I think so. All right, thank you.
And then Dorian asked me, sometimes I don't see the messages. Remember, if you send the messages, if for some reason I miss them, you have to just really unmute yourself and talk. Dorian told me, how do we decide this type 1 and type 2? We don't decide is a type 1 and type 2. For most of the problems, it's possible to do either one. We just decide whichever is easier to integrate. So I will say for this one, I don't like to just do the integration in this one, because that's just a radical notation. Otherwise, if you check these things right over here, it's just done in both ways. So means this is just the one that we have done in type 1, and then the result is the same, and then exactly same process we have done in this. Actually, y is missing right over here, and then we have done it in type 2, and then the answer is exactly the same. So either one is fine, right? But again, if you don't want to do too much radical notation, so maybe you prefer to do type 1, but that's just really not that much different. For most of the problems it's possible. So, but if you remember for the first one that I have explained here, so this is a no for type 2, right? Because type 1 was really simple. It was just one single integration and it works just really nicely. But if I go to the type 2, as you see, there are 3 different pieces or 3 different integrations. It's not wrong, it's just really long. Huh? Darian, I'm fine to move on.
Yeah, you can. Thank you.
Any other question? Any other question? Okay. So the next example is very similar. What it is, the integrand is given to me, so I know what I'm supposed to integrate. So this is right there. And one more time, the main thing is, what's the region of integration to set the limits of integration? I can remind you a few things from the algebra if you don't remember how to graph the parabola. And basically, it's just really get the intersection of the curves and then graph them. So that would be perfect. So look at this equation, because I need to remind you, well, how do you get the vertex in parabola? I'm pretty sure you can remember. It's just really a quick review. So the vertex is going to be minus, the x value of the vertex is going to be minus b divided by 2a. And then in this case, the y value is going to be when you plug in the x value, when you plug in the x value, which is minus b divided by 2a. So minus b divided by 2a, and then plug in minus b divided by 2a to get the vertex. So this is just number 1. And the way actually mine is different, because it's just x first degree, and then y has the second degree. So then same process that we have had in algebra. If you want to get the vertex, you just say y is minus b divided by 2a. So then you plug in minus b divided by 2a, and that gives you the x, sorry. So this is x. Okay, so minus b divided by 2a is the y value, and then g of the minus b divided by 2a is just the x value. So seems mine is really the right left one. So this is going to be y squared. For my case is 2x plus 6. So it's not really a nice way that's supposed to be. What's the reason I am missing this one sometimes? I have no idea. Anyway, sometimes I'm missing the camera, but it comes back by itself. So then I have to move the 6 at the other side to make it in a standard one, and then I have to divide by 2, I have to divide by 2, I have to divide by 2. So sorry, this piece is just too much algebra. So then I have x equals minus half of the y squared, and y minus is plus. And then it's minus 3. So this is going to be this form, right? And then I can get the y value of the vertex. As you remember, really, the main point that you need to get for this graph of the parabola is your vertex. For vertex, it is y equals negative b. So let's say in this problem, a was half, b was missing, and c was negative 3. So this is negative b, and then divide by 2, and then a, which is a half, which doesn't help anything because that's just anyway 0. And then if I plug in back the 0, that gives me -3. So that means this is fine. I mean, that's just really one of the point that I need to graph a parabola, which is my vertex. And then I can get another points because of the intersection. As we know, the main thing that we need to just solve any type of this problem, it is just the intersection, because those are the limits of integration for us. So I have a line of y equals x squared, sorry, x minus 1, and then I have the parabola of y squared equals 2x plus 6. What's the goal is intersection of this one. So I can just plug in y from here to here, right? So I can plug in y from here to here. So means you have x minus 1 to the second equals 2x plus 6. And then a little bit simplification, x to the second minus 2x plus 1 for the left side when you square binomial. And this is going to be 2x plus 6. Then I need to move this one at the other side. Minus 2 is minus 4. Plus 1 minus 6 is minus 1. And that gives me 2 factors. And product to be 5. Addition to be -4. So this is going to be plus. This is going to be minus. Is that fine right now? Do you follow my algebra?
Yes.
Okay. So then I have x equals -1, then I have x equals 5. So these are two. I think this is more than enough, right? So I have 3 points. I can just graph it. So if you plug in -1 in any of this equation here or here, so it doesn't matter because it's really intersection. It gives you the same y value. So that gives you x -2. So the same thing, if I plug in 5 minus 1 is going to be 4, okay? So now I can just say, I need all the way to the -3, and to the 5. So I can just make my graph to be almost longer in the x direction, So this goes 1, 2, 3, 4, and then 5 units here. 1, 2, 3, negative here, because those are the numbers I need. For the 5, it goes 1, 2, 3, 4 unit up. It's right there. And then for the -1, it goes 1, 2, -1 here. So this is -1. This is a -2. And then this is just the points, There are 3 points, and I'm supposed to make a parabola, So let's just make it, this is a parabola for me. That is a parabola which is what? Y squared equals 2x plus 6. And then now is the turn for this one, which is the line. What's the line? Line is y equals x minus 1. So if I plug in x equals 0, the y-intercept is -1. If I plug in y equals 0, the x-intercept is 1 positive, So this is 1, this is 1, this is 1, this is 1. I have more than enough to make a really nice line, I have 4 points to make a really nice line right over here. So this is my line of x minus 1. Okay, and then since this is my, let's just make it, okay. So this is just my region of integration. Okay, so by here, it was just all algebra. All right, I have reviewed whatever you're supposed to know, and then I did it with every single detail. If there is no question, tell me, do you like to make it in type 1 or type 2? Do you like to make it in type 1 or type 2?
Type 2.
Okay, so what is the lowest? So let me say with this maybe color. So if you have, this is the lowest value and this is the highest value, which was, this is not the good one. So this was 4, This is just, if you're supposed to do it in type 2, you said, right? So the y values is going to be all the way from negative 2 to the 4. And then, is there any question with the first one? Am I fine with the first one? Okay. So x1 is the inside one is what you need to be careful. And I always recommend you, please make that leader arrow from whatever direction you're supposed to go. If you are writing for dx, okay, so you're supposed to move in x direction. If you are writing for dy, you're supposed to move in the y direction. So since you are writing for dx, you're supposed to move in the x direction. So then you are moving in the x direction, the first thing that you hit and the last thing that you hit, right? But remember, is writing for the x. It is for the x limits. So it has to be x in terms of the y. So since I have had my x in terms of the y in these steps, actually right over here. So x in terms of the y, it was, let me change this one, sorry. It was half of y squared minus 3. And then the line which is in terms of the y, I have to write it in terms of the x. So in terms of the, sorry, I have to solve it for the x. I'm using drawing board. So if I keep the x, this is going to be y plus 1. So that's the limits of dx, and whatever is inside, I'm not worried about it. Okay, so this is what you have decided, one more time, to make it type 2. This is the type 2. So one more time, the y's was the constant negative 2 to the 4. So negative 2 to the 4 was the constant for the y. X was the next term. So what we're supposed to do is just moving from the left to the right, because it's x. That's how the x-axis is, left to the right. And then when you are going from left to the right, so whatever you hit in the left is really your lower limit. But since you are writing for the x, it has to be in terms of the x. So I'm writing this x equals is just really to remind you. Obviously, you don't need to write that x equals. So this is solve for x in terms of the y. This is solve for the x in terms of the y, okay? So your left one is the blue, which is the curve of parabola. And the right side is just the green, which is that line equation. And that's just really setting the limits, and the next step is easy. And if you have any comment, just add to this one. But if not, let's see why we do not like to try this one in type 1. Anyone has any question? Anyone has any question? Anyone has any question to add? Sorry, I'm trying to see who is here. Anyone has any question? No? So the next one is, can I do this one in type 1? And if yes, what's the problem? Okay, I'm just using that. I don't want to just mess up with my graph. Looks nice right now, so I don't want to change it. So let's just come over here, which is the same graph for the same problem. See what happens if you want to do it in the what we call type 1, right? So what is the type 1? Start with the x's, right? So if you go with the x's, this is the minimum value of the x all the way to the maximum value of the x, which is the 5. And the problem is, when I go all the way from negative 3 to the 5 for the x's, the y's are different, okay? So as I'm moving along the y-axis to see what's the limits of the y, this is going to be different than this part, okay? So this is going to be different than this part. So then that means I have to split it out in 2 pieces. If I decided to make it in type 1, these are not the same. So this left side is starting from the line, ending with the curve, line to the curve, line to the curve, line to the curve, line to the curve. So what's the breaking point? It seems the breaking point is right over here. So this is x equals negative 1. Why? Because that was intersection that we got. So it seems starting from negative 1, it's a breaking point. So you have negative 1 to the 5. So from -3 to the -1, from -3 to the -1 is just similar, but from the what is it, -1 all the way to the 5, they have the same end point, start point for the y direction. So if I supposed to just make this one to be in type 1, I have to make this one to be one piece, and this means you're having from -1 to the 5 for this, and then your what is y is going to be, your y is going to be starting from that line equation, which is yx minus 1, to that what is it, let's just remind you. So this curve was y squared equals 2x plus 6. So then y is plus minus square root of 2x plus 6. Okay, so it's just plus if you are up, if it is minus if you have below the x-axis. Okay, so this is just 2x plus 6 because that's just above the x-axis, right? So this thing, this line is above the x-axis, so it's positive square root of 2x plus 6. And then this line is below the x-axis, so is negative piece of my parabola. So one more time, if I'm looking to the blue highlighted piece, I have started from -1 all the way to the 5. And then the lines are the y direction. I heated this thing first, which was the x minus 1, and then I ending with that line, which is 2x plus 6, okay? And then whatever was my integrand, I'm going to copy later because I don't remember what was the integrand. And then for the other piece, I can make it pink or some other color. So it's this right over here. And then that's starting from -3 to the -1, -3 to the -1 is fine. And then for the dy is going to be the blue line or the blue arrow, sorry, shows, but this is from here to here. So as you see, from negative to the positive, right? So it's just starting from negative piece of the parabola, ending to the positive piece of the parabola, okay? And again, as I said, I don't remember what was my integrand. I have to copy here, y squared plus x, y squared plus x. So is it okay to do in type 1? Yes. Do we like to do it? No, right? Because we don't like to repeat the process or integration 2 times. Especially we hate to work with this radical and integration in the radical or the formula. So then we don't do it in that way because that's just easier. So this is just what we do. It's easier, it's faster, it's just really one part. And then this is just the same answer with 2 times integration. Question, guys?
Professor, I had a question.
Mm-hmm.
I was wondering why we had to break it up into double integrals again for that region.
Mm-hmm.
Like for type 1. That was my question.
Okay. Do you see your what is it, lower limit or lower line from this piece of your curve or this piece of your region is different than your lower line from here to here, right?
Oh,
So
yeah, I see that.
we didn't know unless we just really make these little arrows to set it. So you have to make sure all the way from the -3 to the 5, you are hitting the same line, you are ending with the same line, huh? But this is
Yeah,
different.
okay.
So then we have to split it out.
Okay, thank you.
You're welcome. Any other question, guys? No? And actually, if you look into the slides, you do have both of them is evaluated and is integrated in both type 1 and type 2, and the answer for both of them are the same. So this is the setting that we have done right now. So this is the setting that we have done right now. Sorry, that was highlighted. So from here to here, and then from here to here, and that was just 2 in 2, which we didn't like it, but it gives you the same answer, okay? So you have both ways in your lectures. Move on to the next example. Do you want to add any comment, anything? No? Can we have about 5 minutes break? So this is 3:20 right now. I will stop for 5 minutes and then it doesn't mean I go anywhere. So you're just really waiting for your questions. So this is pausing for about 5 minutes. Okay. But you can just ask questions, or you can drink water, or you can go whenever you want to go, but come back in about 5 to, I will say 8 minutes. It's not really exactly 5 minutes. Any question? I don't know too. I have really no idea what they were doing. The thing is, everything is changing. It's just really one by one. So I will do the lecture, and you have the option, because you see the email from the dean to me and from the provost to me was, you can't, no, that's different wording. I mean, it's just really different. Okay. So the classes are canceled, but you can have recorded video for the students. What does it mean? So means you need to continue your lectures, but it can't be in person, but it could be recorded one. So then I prefer really to have live lecturing than recording, but still is just really same as right now. This is a recording. I'm trying to just find out how to save in a safe place, but this is just really recording. If you are available, you listen to me directly. If not, you listen to the recorded one later. Yeah, because it's up to, I mean, it's just really two options. It says no classes, but it could be recording. So then I prefer to not to make it recording and just make the class in live one, because recording means no interaction. I'm teaching by myself. There are thousands of this type of videos online on YouTube, and I just really set one of them for you, and then you don't need me anymore, right? Unfortunately, however you pause any type of lectures, at the end, the request from the university is these kids must learn whatever they're supposed to learn from this course. Why? Because you are passing a course and you're supposed to sit to the next course, which is just really prerequisite of this course. So means you have to learn something that you needed for future courses. And however we pause anywhere, that's just make us more stressful or more pressure at the end of semester, which we need to finish everything when we come back to the school, or we just doing with more what is it, the recording video. But if we go gradually all the way to the end, then we don't have to worry at the end, because we are just doing everything on time. And as you see, the assignments is getting slower, the group works is getting slower. Nothing canceled, nothing is just really canceled in our class, because it was really same way that we have done in entire weeks. So all group works, voice thread, everything was just really same way. The only thing is I made everything slower, and that's not because of my class. I'm pretty sure you are okay and clear about my class, except the test. but I don't know what the other teachers are doing with you. Do they ask you to do more videos or not? But I'm doing really the same thing that I have done for the last 8 weeks, except it's just really slower. So if it was really like just the original class, we're supposed to cover chapter 12 entirely in this week. I mean, each class 2 sections, but I don't think we go by that speed anymore. And then I actually need one of you to be representative for the class and remind me about the due dates. For the other class, I have made actually one representative. I think it's just going to be almost the same, but we are a little bit behind for the other class, which we need to catch up. So if one person can be representative, which means when I'm sending the email, these are the due dates for this week, check whether I'm right or not. For example, I got an email from Klein, and he said it is the due date is 19, and you wrote Tuesday, and that's just really a mistake. So is it really Tuesday 17 or is Thursday 19, which was really 19? Okay. So if someone can be representative or responsible for emailing me about this type of mistakes, or just really I forgot to extend your homework as we went really slower. So I forgot to extend your homework, and I think I did it last night because somebody reminded me. So remember, you are really one person with one course. I am just really one person with just 90 students. So if everyone wants to remind me something, it's too much emails. But if one person is responsible, and that helps me a lot. Just tell me, okay, we need extension for this one, or this is too much, or this is just really behind. So can we do something different? This type of communication, if we have a representative, we need it right now. That would be just really easier. Any volunteer for this job? Any volunteer to remind me for due dates after sending my email, or checking the assignments, or especially if we are behind, make it slower? Do you no one is volunteer in this room? No? Any volunteer for representative of the class?
Gustavo said he'd do it. It's in the chat.
Mm-hmm. I don't know why I don't see the chats.
I think you can hit a button on the bottom of your screen to pull the chat box up, and then I think there's an option to pull it out into a separate little window, so you can just drag it away.
You see, if I just go this way, I mean, minimize the page, I know where they are. So it's just really right there, and then I can see it. So let's just check whether I have anything. So Gustavo said sorry. Mm-hmm. Yeah, thank you, Gustavo. Then when I maximize this one, I don't see it anymore. Okay. So let's continue. What do we have? We have 2 more examples, and this problem has the graph, but usually we don't have the graph, so we have to start from the very beginning and graph it. this is just finding the volume. One more time, we have to remember, if you are getting the volume, it's just really needs to have some two-dimensional graph to get the limits of integration, and then one three-dimensional to see where is the roof, the top of that graph. So this is just a surface that is given to you, and this is a two-dimensional graph. So that's just for two-dimensional graph, and this is for three-dimensional graph. Okay, so if it has this type of problem in the test, so that's not really given with the graph, and it's really same thing for homework that you can practice. And so you have to do it really step by step, and it seems there are 1, 2, 3, and 4 planes, but these 2 planes I think just really coordinate planes, so I don't have any problem, or I don't need even to graph them, and then it's just really these 2 to graph them. So I'm going to make my graph step by step again. Oops, that was just highlighted. So to remind you some steps, if you don't remember from the beginning of this chapter 10 and chapter 11. So this is X, this is Y, and this is Z. And then the main, or the top, or the integrand, the only Z, right? So let's just one more time to repeat it. I said the main, and then I said the integrand, then I said the Z, and then it's a function of 2 variables. So it's just really this one, the top one. So this is the top one. So if I want to graph this one, I remember from the very first chapter of 10. So this is going to be, first get the x-intercept, which is, oopsie, it was equals to, right? So which is x equals to, and then y-intercept, which is equals 1, z-intercept, which is equals to, right? So I just make my units to be bigger. This is 1 unit, this is 2 units for me, and then this is 1 unit, this is 2 units for me. So x equals 2 is here, 1 is here, 2 is here. So that's just the plane, the integrand, the surface I have. If you remember, I said I don't worry about this x equals 0, because x equals 0 basically means yz plane is right there. This is x equals 0, and then I'm not worried about the what is it, z equals 0 too, because z equals 0 is just really xy plane. So this is z equals 0, which is xy plane. And then this plane, so I have made this plane, I have made this one, I have made this one, I have just really one left. I have really one left, which is x equals to y. If it was in 2-dimensional, was really a line. So I'm just really making the same graph in 2-dimensional. And so again, I just try to make the units to be bigger. Then I have more clear graph. So it's 1 unit, this is 1 and 2 units. So as of now, I have 2 and 1. So I have had x is 2 units, y is 1 unit. So this is just really the line, okay, of whatever I have in here in the bottom piece for 2-dimensional. And then what I'm trying to do is just really this one. So if I just learn from algebra, this is 0, 0, you can go by slope, however you like, okay? If I say, plug in x, y to be 1, x is 2, so this is going to be 2, and then 1. So it's right there. This is, okay. Let me just make a different color. So this is going to be, if it was 2-dimensional, this is going to be x equals to y. And if it was 2-dimensional, this was the line of x plus 2y equals 2, okay? Okay, so but I need to transfer this one. Okay, so let's say transfer. I'm using the same color. I'm transferring my blue line. Okay, so I'm just trying to transfer my blue line. So this is just the one. If it is the parallel line, this is the parallel line. Okay. Oh no, undo, undo. Okay, so my lines to be parallel, it's almost here, which is the x value to be 2, the y value to be 1, and then that's just passing the origin. So that is passing the origin. It's somehow right there. I can just make it a little bit more slanty, then I can just have a nicer graph. Maybe I can make it like just really this much. So this is 2, 1. Okay, so then if I make a just a plane or stretch it in the what is it, z direction, because it's missing z, that is going to be another wall. This is going to be another wall, and that's just breaking point. Okay, so the two-dimensional graph that I'm looking for is here. Why? Because it does have the x equals to y, and then it does have x equals to y. It does have x equals 0, which is the y-axis, and then this line, the black line, is coming from the plane. So this is just going to be two-dimensional graph, which gives me the region of integration, and this is going to be the three-dimensional graph, which now I need to make the z as a function of xy. Okay, so because originally the plane was like this, but if you want to just integrate, you need it to solve it for z, right? So you need to solve it for z. Okay, and now I'm ready to decide whether I want to set this one to be type 1 or type 2. Any idea? So Ricky, type 2. So Ricky, type 2. So then I will go from 0 to 1 for the y. Type 2 means y is constant. Okay, so type 2 means y is constant. So this is just the, if I make the highlighter again, so this is just the y directions, right? So the constants are from 0 to 1. So the constants are from 0 to 1. And then the next 10 is for the x. So the next 10 is for the x. So you have to make it. So let me just pick the nicer color. So then if you are going to the x direction, see, this is starting from here and ending by here. Seems this is fine. Seems this is fine. Not anymore. Do you see your ending line here is not the same as your ending line here? So can I do it in type 2? Yes. Do I like to do in this way? No. Huh? So then can I do it in type 1? I will do it, sorry, type 2. I will do it later, but for now I just do the easy one, right? So let's just say you have to do it in type 1. So then their x is constant. So your x is constant. So you have started from 0 all the way to the 1. You have started from 0 all the way to the 1. Then dy, for the dy, so I don't have any other color. Where the colors are coming from? maybe red. Okay. So if I want to move on the y direction, first is this, then is this. So this is the y equals half of x, the blue line, and the black line was, I don't know. Let's just solve it. Okay. So originally was x plus 2y equals 2. And then if I solve it for y, I move x at the other side, divide by 2, divide by 2. Okay. So negative half x plus 1. Negative half x plus 1. Okay. And then this is going to be one single line, right? So it doesn't matter you are here, you are here. It's always starting from blue all the way to the black one. Blue all the way to the black one. Sorry, this line was originally black. I'm going to make it black. Okay. So this is just, again, I just make it, what I'm doing is dy. So that's why it's, the breadths are all in terms of the y's, or is in the direction of the y's. Okay. So if you don't have any question, can you tell me what's my integrand? What do I put as the function of xy? So what is my integrand?
I have a question.
Please.
Well, it looks like they're ending on different lines, just like the type 2. Like, you know, how the type 2 ended like different lines. This one.
Where do you have a pen or pointer somehow in your side or no?
Let me see if I can do it. No. So, dy, it ends on the, let me see, on the blue line, and then it ends on the black line.
No. It doesn't end on the blue line. It starts at blue line, ends at black line.
Oh, okay, I see. Oh, I see now. Okay, I see the difference. Yeah.
Okay.
Yeah.
Any other question?
Yeah.
Any other question? Okay. So then did you tell me what's my integrand, or what's my surface that I supposed to integrate over, or what's the roof of this graph? Maybe this is just better. Maybe this, what is it? Graph is better. So this is showing the only surface that you have, or the top is just whatever is in terms of the z. So remember, you are integrating a function of xy right over here, which has to be in terms of the z. So if you want to get it as a function of xy, so that's supposed to be 2 minus x minus 2y, which I've done it over here one more time. So this is just what I have, right? Okay, so for this type of problem, as of now, there is no other things. It's just really one of them, okay? So it's 2 minus x minus 2y. I wish I could erase the other arrows, which we didn't like it. I can't, right? I don't want to keep this much arrows. Right? This looks like better. Yeah. No? Okay, that's enough. So the reason is, if I want to do in type 2, I have to really make it in different. I never make it in the same, because that gives you too much, arrows in one graph, and it's just really confusion. So if I want to do it in the other type, I prefer to move to just another graph, okay? So let's see, this is exactly same graph that I have on top. So if you want to make it complete, I will just say this is 1 to 2, and this line was the black line on my graph, and then this line is just the blue line on my graph, and then the intersection is clear, it's just really right there. We can set the lines equal. So this line, the blue one, is x equals 2y, and then the black one is just x plus 2y equals 2. So then, as I said, I've decided to make it in type 1 because it was easier. But if you wrongly decide to do in type 2, it seems these are two pieces that you need to worry, because this piece is different than this piece. Okay, so why they are different? Because if you are decided to do in type 2, you have to start with the y first, but from here, which is 0, to the here, which is half. If I just make it in just blue color, this is the start point and this is the end point. So you have started from 0 and end up with the 2y for the x. Okay, so whatever is your integrand, I don't remember, I have to copy. And then if you have the second piece, so you have started from here and ending here. So it's just really half all the way to the 1. But this time I just use this color. This is the left, this is the right. So this is going to be 0 and the right is going to be something in terms of x, I don't know. Okay, so let me just write down what is this one in terms of the x. This one in terms of x is 2 minus 2y if I move the y at the other side. So it's just 2 minus 2y. And then whatever is the integrand, I need to copy my integrand. I think it was originally the plane equation of x plus 2y plus z equals 2. So z is 2 minus 2x, minus 2y minus x. So 2 minus 2y minus x, 2 minus 2y minus x. Again, do I like to do in this way? It seems not a good idea because it has to be 2 times integration of same thing, right? So this is 1, this is 2, and then add up the result, which we don't prefer to do it in this way. Question? Any question? Can you explain the graph again, please? I'm not sure how you get there. Okay. I'm not sure how you get what. I missed that part. I'm not sure how you get the integral on xy plane. The xy plane, okay. So this means go back here. Okay. Go back here. There are always 2 graphs. One of them is, there are always 2 graphs. One of them is 3-dimensional, the other one is 2-dimensional. And how do I started with that triangle? That's just really good question, because that triangle must be always the base for my graph is right there. So this is just the triangle. That's what actually, this is the triangle. Okay. So when we are integrating this f of xy dA, and this is really what the base is. Okay, and this is really what the roof is. Okay, so this is the top of whatever is the solid, and this is going to be whatever is the base one. So where the triangle is coming from is just the shadow or the base of your graph on xy plane. Okay, so since you have had one over here, which is x equals 2y, so that gives you one line of x equals 2y. So you know how to graph x equals 2y by plugging numbers. So then the other line, which is usually confusion for students, is coming from here. okay? So that's just the other line, which is right there, right? So that is exactly the plane equation when you plug in z equals 0, right? That's just your plane right there. This is your plane right there. So let me use different highlighter. No, yes, it's not working. Yeah, okay. So this is the plane which is right there, okay? And then when you have the line of intersection, since it's on xy plane, all you need to do, you need to set the z equals to be 0. So that's why the other line that I have graphed is x plus 2y equals 2. So this is the line of x plus 2y equals 2, and that's just really the base triangle. So that base triangle, which is right here, is really this one with 2 lines, okay? If you want to graph it two-dimensional graph, remember there is no z value in the xy plane, so you have to set the z to be 0. Make sense? Make sense? Okay. Any other question? Any other question? Okay, the next example is not possible to do. So if you remember from our calculus one, this function is not integrable. Why this function is not integrable in terms of the y? Because what I know is if I plug in u or substitute u to be this one, so then I need to have 2y dy to be my differentiate of the u. But I don't see any y right over here. So means I cannot, this is really impossible to do in terms of whatever it is, right? How do I make it possible? I have to reorder this integration. If you reorder this integration, it's fine to integrate in terms of the x. So when it's fine to integrate in terms of x, you can just change the term, do in terms of x and get the result, and then do in terms of the y, okay? So the main thing that I need to remember, and I have seen right now for many examples, switch the order of integration doesn't mean really switch it without any steps, because as you've seen over here, type 2 was so much different than what is the type 1, okay? So type 1 looks like this, type 1 looks like this, and then type 2 looks like this, okay? So you can't really come over here and say, okay, this is not possible, I want to reorder it, so that gives me dx dy, and then that means whatever goes with the x sitting here, and then whatever goes with the y sitting here. No, that's just wrong, right? This is wrong, because as we've seen, it really depends on the graph, so it shouldn't be exactly the same switching right over here. There are many changes, depends on what type of triangle, parabola, or whatever we have had. So what's the solution to not do this mistake? You have to go back and just really see what's the really exact graph. What's just really when you plug in or switching from type 1 to type 2, okay? Let me erase these extra things because I don't think we need to keep them. Okay, so then always for such a this problem, which is in your group work, I ask you exactly change the order of integration. But here it didn't say change the order of integration. You need to guess this is not possible to do in dy dx. I have to switch the order of integration, okay? So this type of problem is the same as change the order of integration that you will see in your groove work. So then I have to always see what's my graph. So you have to graph the region of integration. right? I don't care what is really the graph of my function, means I don't care about this function, I care about what's the region of integration. So since I have to set the x's to be between 0 to 1 because of this, and then the other thing is just the y's, which the limits of the y's is between x to the 1, okay? So I have to remember inner one is the main one. For graphing, this thing should be the first. The inner one is the main one. So that you have to graph the inner one, then you are done, okay? So you don't need to worry about the outer one. So it looks like if you have the y equals x, which is the left limit, oh sorry, I should call it down because it's a y, and then the y equals 1, which is just the upper limit, then I can get the graph. So I know y equals x is right there, and then I know y equals 1 is right there. So this is the region. That's it, right? So mainly I meant to just say, I don't know why I lost my one. So I just say, if you have the graph, so if you somehow you need to graph the region of integration, so whatever is inside is just what you need to graph it. So this is the inside, so then you have to graph the inside, okay? Now, step number 2, change the order of integration. Right? So this means you had originally dx first or type 1, now you want to make it type 2. So if you want to make it type 2, you have to first write the dy, the limits for the dy, okay? The limits for the dy is starting from 0 to 1. And then for the dx, I'm moving on the x direction, and lower limit is 0, upper limit is, I'm moving on the x direction, okay? So is y, not x. Is that true? Because it has to be limits for the x, so it has to have the y, okay? So then whatever was my function is just really perfect or easy to integrate in terms of the x, right? Because that's a constant, right? So let's do it to see what happened. I keep the outside to be exactly the same, but e to the y squared in terms of the x is going to be like this. You plug in 0 to y. So then you have e to the y squared, and then you plug in y, and then you plug in 0. So this is really what I was looking for, right? So my problem was if I take u to be y squared, I did not have my y to make the du, but now I have it. Now I have that y over there, and that just should be my du, okay? Which is giving me e to the y squared half. And then you plug in the limits, plug in 1, and then plug in 0. And that's your answer. Any question in any step? Any question in any of these steps?
Could you go over how you change the inside limits of integration again for underneath step 2?
The original order of integration is just really to find the region of integration, huh? So this is just to find what's the region of integration, which says your x's is between, your x's is between 0 to 1. So your x's is between 0 to 1, and then it says sorry, it says your voice is between x to the 1, okay? And then when I graphed it, I'm not worried about what I have had right over here as the original problem, because this is given, I mean, you have this region of integration right over here, and then that is supposed to be, originally was type 1, now it's supposed to be type 2, okay? So then I just start to rewrite this one in type 2, okay? So if you want to write this one in type 2, it's not really coming directly from here to here, it's not, okay? So that's not the way that we go. It's just first make the graph and then write the region of integration in type 2. You can't go directly from here to here and change it, as I said, because it's just really so much different when you just make it in type 1 and type 2. Or make it from dx dy to dy dx. So it's not going from this way directly, but it's going to first make the graph, and then from that graph you can set the limits of integration. So if I'm checking the limits of integration right over here, so for the dy, you're starting from 0 all the way to the 1. So you're starting from 0 to the 1. And for the dx, you have this red line is moving from here all the way to here, right? So moving from the, I can make it another red line. So moving from here and then all the way to here. So this is the line of x equals 0, because that's the y-axis. And the end line is going to be the line of y equals x. So I need for x, so I need to write x equals y. So this is x equals y, this is x equals 0. And then that's just the limits of integration when dx has to be inside.
Okay, thank you.
Make sense?
Yeah, it does.
Any other question, guys? No? Okay. These things I actually reminded you last time, whatever rules that we have had in calculus 1 works nicely over here. If you have integration of addition, you can split it out and write the integration of addition of integration. If you have any scalar, it's just perfect to factor it out as we did it in calculus 1. If you have any inequality, so you can just integrate both sides of the I mean, you can double integral both sides, you can single integral both sides of the inequality, you can triple integral both sides, so it doesn't change anything. And this rule we have used a few times, so we split it out. So if you have two regions, which is just really for type 1, type 2, you need to break it down into pieces. So the result of one single integration is going to be when you split it to these two pieces and then add up the result. So we have done a few problems. So it's going to be same thing. You can have more pieces. It doesn't have to be two pieces. So you can have more pieces. The equation number 10 or the property number 10 of your book is just really same thing that we have had in calculus 1. I need to remind you over here. So in calculus 1, what was calculus 1 version? So it says find the area between two curves, right? So when you have between two curves, and then it was just really making the graph, you have had one, it was f of x, then you have the top part, which is g of x, and then this is the intersection from A to B. Calculus 1 version says to find the area, you go from A to B, and then y top minus y bottom, dx. So this is going to be just the top piece, and then this is going to be the bottom piece, right? So then you go y top, which is just for this graph is g of x, minus 1 y bottom for this graph is f of x. And that's it. Okay, so this is a calculus 1 version. I'm just saying this is the same thing because there we didn't know double integration. This is the same thing when you go from a to b of d of x and you set the limits of integration to be this direction. So you're going from the lower limit, which is f of x, to upper limit, which is g of x. Is it the same? Are these two the same? No? Yes?
Yeah.
Okay, so these two are the same, so that's what it says. In order to get the what is area, you can use the double integral, right? So you can just use the double integral, but you don't have integrand. Your integrand is 1. Okay, so you can set the limits of integration on the 2-dimensional region. So this is my 2-dimensional region. I can set the limits of integration without the integrand. So not only the double integral gives you what you call volume of the solid, it gives you the area too. What's the difference between these two formula? For finding the area, you don't have integrand, you're just integrating from 1, but for finding the volume, you do have integrand because you need to integrate over the roof or the surface that you're supposed to have, That makes sense? Okay. And that's the geometric reason behind of that. Last thing that I have to move to the new section. This is so what's the first statement? The first statement says your function is bounded between two values. Do I know any function to be bounded between two values? Yes, I know some of them. So for example, I know sine of x is bounded between two constants. There's no way to be bigger than the 1. There's no way to be less than -1. I know cosine of the x is bounded between two numbers. Okay, we don't know that much. We know really limited, just number of functions which are bounded between two values. And then the rule says it's fine to integrate all sides, right? So you can integrate all sides of your equation. You can integrate all sides of your equation, and that's it. It doesn't matter, it's just inequality two-sided or just more sides. So you can integrate all sides of the equation. Why do I need to do this? I mean, do I need to know this property of the integration? Because there are something that there is no way to integrate. I cannot call this one to be u, and then the du is just really something long, right? So this is just this u. So then du is it has to be product rule, and that's just really not what we are interested to do. Okay, it's not what we can do it, or we can integrate it, but can I estimate it? And that means really using the property of y, because sine and cosine are remitted, so sine and cosine are bounded to values. So yes, you can just really estimate it, but you don't know what's the exact value of this type of. So there are many of these functions that we don't know how to integrate, but at least we can have a good approximation. Okay, and for this one, as I said, since sine is bounded and then cosine is bounded, then the product of them is going to be bounded. So what it is just this function is bounded. So this function is bounded, and then I can e all sides. So e to the -1 to the left, e to the sine x cosine y, and then e on the right side. And then I can double integral all sides, dA. dA. Okay, so this is my original problem that I'm looking for estimation. Okay, so this is just really my estimates. These are really my estimates. So I don't know what's the value, but I know it's going to be e to the -1 integration of dA. I'm factoring out because that's a constant. And then e to the sine of x cosine of y, and then e factor out integration of dA. Let me rewrite it. Okay, so just now we said this is going to be exactly the area. Integration of double integration of nothing or 1 is going to be the area. Area of what? Area of this. Right? So area of what? Area of the region of integration. Region of integration is going to be a circle, pi r square. So this is e to the -1, 4 pi, and left side is e times 4 pi. So again, I don't know what's the exact value, but this is estimation. This is the estimation. Make sense? Any question? Do you have any question?
So like what you're doing here is you're kind of you're making two circles, one with the amplitude of e to the -1 and one with the amplitude of e, and the area is in between that.
Exactly.
Okay. Thank you.
Any other question? Any other question? Should we move on? Okay. I really don't know where this thing's saving right now because, as I said, I'm really new in OneNote. I need to find out how to just whatever is saved here during the teaching and whatever is recorded, I have to just somewhere in titanium provide for all of you guys, but I need to find out. It's just really learning how to work with OneNote. Okay. Now I want to move to the new section, but before that, I'm going to stop recording and make a new record, okay? This is just because we can have different records for different sections.